My name's Will, and I'm the Digikey Ambassador for Purdue University. And today, I wanted to share with you a project I've been working on with some of the great components found on Digikey.com. The Google Home-enabled Smart Barista. All projects need at least some sort of inspiration. For me, my inspiration came from a group of fellow makers who designed and built a drink dispenser for their house parties. Now, I really enjoy making coffee in the morning, but sometimes I really hate the time that it takes to do it. So then it hit me, why don't I take their design for a drink dispenser and integrate it into something that could pour me coffee in the morning? But I didn't want to have to look at a tiny screen every time I woke up and cycle through the menus, so I decided to integrate my project into Google Home automation. So now I can just say, hey Google, make me a vanilla cold brew. The main construction of the Smart Barista is wood that I just found at the local hardware store in order to keep the cost down. However, I did use 3D modeling and 3D printing in order to make the custom front lettering and the Purdue themed coaster for where you set the cup when it's dispensing the drink. Things get really interesting when you take the top cover off and see what makes the Smart Barista so smart. The system uses a 12-volt switching power supply to step the 110 volts alternating current down to the 12 volts direct current needed to run the 8 pumps on the back of the barista. From there, the 12 volt lines runs to a power distribution board and then to a relay board so each signal can be independently turned on or off depending on what drink is being made. For controls, the 12 volt power supply is then stepped down to the 5 volt power supply needed to run the Raspberry Pi and the NeoPixel LED strip. The enclosure was specifically designed in order to mimic other smart dispensers that can be found either in fast food restaurants or even things in the home. However, special care was made in order to make sure that the electronics stayed above where the liquid was going to be dispensed in order to avoid a lot of unfortunate accidents. To pump fluid through the Smart Barista, I used a rather unique style of pump called the peristaltic pump. These pumps work really well at pumping beverages because they use a unique form of pumping like this straw. Basically, they pinch one end of the tube and draw that pinch forward, effectively pushing the fluid on this end out the other end. This is especially important for beverages since none of the moving components will actually ever touch the fluid. This means if something breaks, the fluid is less likely to touch electrical components, and if something gets dirty, it's very easy to take the pump apart, replace the dirty tubing, and then put in more clean tubing. Like I mentioned before, this system runs on a Raspberry Pi, like the Model 3 that I have right here. But what makes this device so special is the implementation of something called a Docker container, which allows me to run the Barista software in its own stripped down operating environment. By allowing the Barista software to run in its own environment, I can ensure that this software will run on any system that supports Docker. This is especially useful in case I ever want to build another one of these devices, or if something happens to my Raspberry Pi and the image gets corrupted and I have to start over. But that's enough about the hardware. Let's jump into the software. The pump's configuration file tells the barista what ingredients are connected to each pump. The device supports up to 8 ingredients and will only allow you to make the drinks with the ingredients that are connected. This way you can't accidentally make a drink with missing ingredients. Next, the drinks.py file is where all of the recipes are stored. It's really easy to add more, and since it's just the database for the barista, you can add as many as you want, and the pump's config file and the menu file will make sure to only pull recipes that you have ingredients for. Finally, you have the barista Python file. This is the main control file that sets all of the different operations. It is here that the barista tells the NeoPixels to turn on and to animate, and for the pumps to turn on and off as different ingredients need to be dispensed. It's also where different parameters are set, such as the pump flow rate, and if you're using a screen, different screen height and width settings. In order to connect to the internet, the barista needs to run its own web server. When the Google Home sends a request, it posts a webhook on this server. The data from that webhook contains the drink name, and then the server searches through the menu from the barista file for a match. If there's a match, it makes the drink. It's actually really easy to make an applet with IFTTT. The first step is to choose what you need to say for the Google Home to react to your command. For me, I chose make me a and then whatever drink I'm using. Next, you want to program what the assistant should say in response. Sure thing, pouring you a black cold brew. Finally, you have to tell it where to make the web request. For me, I use webhook relay, so I choose the webhook relay URL and a post webhook. After the webhook is sent, it needs to be sent to the correct server. At home, it's easy to port forward the web server to allow it to communicate with the IFTTT service. But while I'm at school, I use a service called Webhook Relay to receive the webhook from IFTTT and send it to the barista without needing to mess with network settings. Alright, that's enough explanation for now. I think I could use a nice glass of cold brew. Hey Google, make me a caramel cream cold brew. You might be wondering how easy it is to clean a system that has so many different tubes and so many different fluids like creams and syrups and coffee running through them. Well, turns out all I have to say is, hey Google, clean the barista, and all of the pumps turn on for a short period of time, allowing me to run hot water through all the tubes. Then, about halfway through the cycle, or as I see fit, I can pull the tubes out, and since the pumps are peristaltic like I mentioned, they'll suck air through the tubes, purging the lines of any of the excess water. This keeps the barista very clean, and only rarely does it require any extra cleaning. Working on projects like this one really allow a student like me to take the theories that I'm learning in the classroom and apply them towards devices and technology that I might encounter in the future. If you're like me and you're looking for inspiration on your next personal project, make sure to check out maker.io for project inspiration and tutorials. But until then, thank you for watching and have a great time making.